Hey guys, it's Eddie the Magic Monk. Today we're going to talk about what mutually exclusive events are and how we can work that in with our probability trees. So let's give you guys an example. Two events are mutually exclusive if they cannot happen at the same time. Okay, so let's just give you the basic example of two events that are mutually exclusive. So event A and event B. If we said event A is rolling a 6 on a die and event B is rolling a 5 on a die, you can't roll a die and get both a 6 and a 5. So these two events cannot both happen at the same time, so they're mutually exclusive. So what's the formula for mutually exclusive events? The formula for events A and B, if they're both mutually exclusive, then the probability of A or B occurring is equal to probability of A plus probability of B. So what does that mean? So explained in plain words, it means that the probability of getting a 5 or a 6, so getting either of these is allowed. Okay, you either get a 5 or you get a 6. What's the probability of getting either of them? So the answer would be probability of A. So probability of A is 1 out of 6 because only one side has a 6 out of 6 sides. And the probability of getting a B is again 1 out of 6 because you're tossing a die. So the probability of getting an A is 1 over 6 plus probability of getting a B is 1 over 6. So the answer is 2 out of 6, which is 1 over 3. Right, so that's the probability of getting a 5 or a 6 on a die. So that seems pretty easy. How does that relate to the probability tree that we've been talking about? So let's say we run an experiment where we toss a coin 3 times. Starting from the beginning, we have one layer in the tree diagram. We either get a head or a tail, and then we toss the coin again, so we could either get a tail, head or a tail again. So that's the first toss, second toss, third toss, and then we write out all of our outcomes. So at the top we got 3 heads, 2 heads and a tail, head, tail, head, head, tail, 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 head, head. And each of these probabilities, probability of achieving this outcome would be half. So all of these are halves and so on. So it would be probability of getting 3 heads would be half times half times half, which is 1 over 8. And then it'll pretty much be half times half times half for all of them. So it'll just be 1 over 8, because if you multiply along the branches, it'll always be half times half times half. So the end result is always 1 over 8. So if I asked you what is the probability of getting 2 tails, how would you answer that? Well, firstly, you've got to look at all of these outcomes and you're going to see which ones have 2 tails in them. So this one has 2 tails, this one has 2 tails, and that one has 2 tails. Now, what do we say about these 3 events? These 3 events are mutually exclusive, right? Because if you get 1 head and 2 tails, or you get tail, head, tail, these things cannot happen at the same time. Either this has happened, or this has happened, or this has happened. These 3 things, they can't simultaneously happen. So you can write the probability as probability of head, tail, tail, or tail, head, tail, or tail, tail, head, right? So that's the probability of getting two tails is equal to these three possibilities. So then equals, now using the formula for mutually exclusive events, probability of A or B is equal to probability of A plus probability of B. So you would go probability of head, tail, tail plus the probability of tail, head, tail plus the probability of tail, tail, head. So what's the probability of getting each one? Well, we just said previously they're all 1/8. So it's just going to be 1/8 plus 1/8 plus 1/8. So the answer is 3/8. Okay, so let's do another one. What is the probability of getting one head? Looking at the tree. I'll let you guys do it first and figure it out and come back and check the answer. What is the probability of getting one head? Okay, so now let's go through the tree. Let's look for possibilities with one head. So we got, oh, sorry, that's exactly the same, isn't it? Well, that's embarrassing. Let's change that to one tail. So let's go through this and look for ones with one tail. So that's one tail, that's one tail, that's one tail. So the probability of getting one tail is probability of head, head, tail, or what's another? Head, tail, head, or tail, head, head. So then that's probability of head, head, tail plus probability of head, tail, head plus probability of tail, head, head. So then that'll be half plus half plus half. Oh, why am I writing half? It's 1/8. So 1/8 plus 1/8 plus 1/8, which is 3/8. So that's the probability of getting one tail out of 3 coin tosses. Okay, well, I guess that concludes our lesson on mutually exclusive events. Thanks for watching, guys. See you next time.